Does terraforming a tidally locked planet make any sense? Are the images we get of our galaxy's supermassive black hole fake? Can we observe gravitational waves that came before the cosmic microwave background? And in Q&A Plus, who is currently working on space elevators? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Poshact, what is the feasibility of terraforming a tidally locked planet? It all depends on what you're hoping to do with your terraforming process. But the biggest issue with a tidally locked exoplanet is that it is tidally locked, that it is showing the same face to the star all the time. And what you end up with is half of the planet is in eternal sunlight, and then half of the planet is in eternal darkness. And then you've got winds that are redistributing the air from the cool side to the bright side, and vice versa. So one side of the planet would be habitable, the part that's facing the star, and the other part would be uninhabitable because it would be incredibly cold, completely frozen. Wouldn't be as cold as if it had no atmosphere, but it would be very cold, more than 100 degrees below zero. And no sunlight. And so life wouldn't be able to exist on the dark side. And people have thought in the past that the near side is going to be uninhabitable, that it also is going to be like a superheated desert. But now it really looks like the simulations show that the near side is going to be more like a jungle. So it's going to be very humid. It depends on the amount of water on the planet, but it's going to be very humid. There's going to be a lot of clouds that you will have, and depending on how far away it is and how much sunlight it's getting and more there's all kinds of, it depends. But you could easily end up with a world where half of it is in eternal sunlight covered in jungle, and then half of it is eternal darkness. And that would be interesting and weird, and doesn't mean that life couldn't get a foothold. Now we as human beings might show up and go, yeah, the eternal sunlight is fine with us. It's always daytime. It's never night. That's all right. Plants grow, and they just, we know that plants can grow in eternal light. They're not super happy about it. They like a little bit of rest, but there are plenty of people that put plants under grow lights 24/7, and the plants can survive. So it doesn't feel like any of that is completely uninhabitable. But if you did want to terraform it, and you wanted to stop it from being tidally locked, you would probably bring an asteroid close by. An asteroid would fly by very close. It would cause a gravitational jerk to the planet and maybe start it spinning just a little bit. But the problem is that you are fighting the inevitable tidal locking from the star. It always wants to get back to being tidally locked. And so if you were able to figure out how to bring a lot of asteroids in to do flybys, you could slowly start to speed up the rotation of the planet, but the star is always going to be trying to drag it back down. So it's going to be kind of endless. And so I don't think it's worth it. I think you adapt to this weird, cool jungle world. It's got these more temperate climates around the terminator between the night side and day side. It's a weird, fascinating world, and you just roll with it. J. Drummond, why is it okay for space companies to dump failed rockets into the ocean? Wouldn't this be considered pollution in any other industry? Are there rules or efforts to recover that debris? Well, it depends on the rocket system. So now, say the Falcon 9, which is like the most common rocket, the first stage booster lands and is reused. So you don't get the loss of the first stage booster. The upper stage generally goes into orbit, so it's not crashing into the ocean. So the amount of booster rockets that are actually crashing into the ocean now is very low. The Space Launch System has launched once and crashed into the ocean. You will occasionally get other launch providers, Atlas, stuff from United Launch Alliance, a couple a year. Europe, their Ariane rockets land in the ocean, their first stage, but they only launch a couple of times a year. The Chinese are definitely, they drop them on villages. I mean, they drop them on land, but they do drop some in the ocean. So, I think the entire industry is moving towards reusable technology at this point, especially, if Starship actually works, then the entire stack is reusable. The first stage is reusable and the upper stage is reusable. So that's the direction that the entire industry is inevitably going. And when you think about the number of, the amount of rockets that are actually dropped into the ocean compared to the amount of ships that are sunk, the amount of garbage that is dumped into the ocean, the amount of plastic that drifts down rivers and goes into the ocean. I mean, there are some big polluters of our oceans right now that, if this is a concern, we should solve that problem immediately. So I think, like all things, right now, the problem is tiny. The amount of debris that's dropping in the oceans is minuscule compared to the kind of garbage that's already happening. But like all things, it's a tragedy of the commons problem. And that if you just keep turning a blind eye to it, then people will keep doing it. And eventually it's going to become a bigger and bigger problem and lead to serious pollution. But, you'd be looking for a lot more rockets to be launching for that to be even hold a candle to some of the other environmental disasters that are being unleashed on planet Earth right now by various people who aren't having to pay the consequences of what they're doing. Scott Smillie, I heard that the picture of Sagittarius A was modeled after what the researchers thought it should look like and not a true representation of the black hole itself. Can you clear this up for me? So I'm assuming you're talking about the image from the Event Horizon telescope that shows the black hole at the heart of the Milky Way. And it's real data, right? They really did take radio dishes around the world, turn them into a virtual telescope, and point them all together at the supermassive black hole at the heart of the Milky Way. And then all of them acted like a telescope that was the size of planet Earth. And it is the highest resolution telescope that has ever been made because, you've got a telescope that is thousands of kilometers across. But the first thing to understand is that they were gathering their data in the radio waves. So not visible light, but they were gathering radio waves. And so, what does it mean to see radio waves? When you're looking at pictures that come from James Webb, they're in infrared. What does it mean to see in infrared? You can't see in infrared. You can feel infrared. But if you want to be able to see infrared, you've got to wear special infrared goggles, or you've got to take a picture with an infrared camera and then look and then have the infrared camera shift the wavelengths to wavelengths that you can see. So that's part of it. And then the other part of it is that it was an enormous amount of data that was required to be able to crunch down, to be able to produce that final image. And the image is not even the event horizon of a black hole. It's the shadow of the event horizon of the black hole. But the features that are in there, the way the gas is moving around the black hole, the orientation, all of the things that are in that picture and the things that helped the astronomers be able to confirm their calculations. So there are real data in that picture that astronomers are able to use, but obviously they had to colorize it because you can't see radio waves. So, there is, people always have this concern when, whenever there's an image that's taken in a wavelength, like James Webb, right? That's taken in a wavelength. And people are like, well, that's not actually a picture. That's not actually a photograph. No, obviously, but it's real data. And the data is being presented to you in a way that you can see it with your eyeballs that are designed, that evolved to see in the visible wavelengths. And so it's the same process. It's time to shout out the new $5 patrons and above: Peter Wilson, Dwayne Shea, One Step for Animals, Bob Hurd, Chris McNabb, Dan, Jake Hopkins, Emmanuel Bala, Ryan M. Pearson, and Austin Tanner. Join the club at patreon.com/universetoday. Richard R. If we launched a space telescope 1 light year away to orbit something, would that expand our observable universe by 1 light year? Kind of. So what would happen is that if you took a telescope and you sent it to another star system that was a light year away, it would be at the center of its observable universe, and we would be at the center of our observable universe. And so things that are happening, so if you sort of imagine, right, the two stars are side by side, and then we've got a side of the universe, and ours is 1 light year further, and then they've got their side of the observable universe, and theirs is 1 light year. So if things are coming their way first, then they'll see it, and then we'll have to wait a year before it becomes part of our observable universe. But if we see stuff, then they'll have to wait a year before it becomes their part of the observable universe. You can sort of run this analogy with sound, right? Imagine you have two friends. You have one friend move 500 meters away from you, and then there's a loud sound. You hear the sound first, and then the other person hears the sound because the sound has to travel from the location. But it doesn't make the observable universe one light year further. It just, you now have independent observable universes around you. Michael Blacktree, would we be able to detect gravitational waves from before the CMB? And would that tell us anything useful about the early universe? Theoretically, yes. So the limit that we can see in the electromagnetic spectrum is the cosmic microwave background radiation. This was a time that was 380,000 years after the beginning of the universe. And that is the limit. That is the earliest in time that we can see. There's no way for us to see with our telescopes earlier than that. But gravitational waves and neutrinos can move through that opaque material that was there earlier on. And both were almost certainly being generated and sent out into space. And so with both a neutrino telescope, in theory, we should be able to detect neutrinos from earlier than the cosmic microwave background and gravitational waves. And the greatest thing would be able to detect the gravitational waves, the aftershocks of the Big Bang itself, because that was a time of large amounts of mass moving around. And there have been researchers who tried to see they're called primordial gravitational waves. And researchers have tried to see them like some kind of influence of these gravitational waves on the cosmic microwave background, that as these gravitational waves were moving through this earliest material, it would have like changed the polarization of this early material, and we would see this signal in the CMB, but it hasn't happened yet. But people are still trying. You're probably familiar with the LISA mission, the Laser Interferometer Space Antenna. And this is where you're going to have 3 satellites flying in formation, and they're going to be firing lasers back and forth at each other, and they're going to be tens of thousands of kilometers apart. And as a gravitational wave sweeps past them, then it will change their distance a little bit from each other, and they will be able to measure that change in distance, and they'll be able to detect the gravitational wave. And while the ground-based gravitational wave observatories kind of top out at merging black holes, LISA should be able to detect merging supermassive black holes. But LISA was thought of as like the first step of a much larger gravitational wave telescope, something called the Big Bang Observer. And this would be a constellation of 12 LISAs flying in this sort of dodecahedron. Isohedron? 12-sided die. And then as the gravitational waves swept by, they would sort of shift their distance from each other. And it theoretically could be sensitive enough to detect these aftershocks from the Big Bang itself. And if we could, that would be mind-bending, because it would be this deep insight into the exact conditions that were happening early on in the universe. And unfortunately, we probably won't see a gravitational wave observatory with that kind of capability into the 2050s, 2060s. So people have this on the books. There are papers. I've reported on it, but we're a long, long way away from that actually becoming a reality. But wouldn't it be amazing? Uğur E. When we're in the solar system, we orbit the sun. After we leave the system, do we start orbiting the black hole in the center of the Milky Way? Right. So we are on the Earth, and the Earth is orbiting around the sun, and the Earth is going 30 kilometers per second around the sun. And that if you get into Earth orbit, it takes, I forget, like 7.5 kilometers per second to get into Earth orbit. And then you need about another 12 kilometers per second to escape the solar system. And so once you escape the solar system, you are now moving through interstellar space. You have escaped the gravitational well of the sun, and you are now orbiting like the rest of the stars in the Milky Way around the center of the Milky Way. And yeah, at the center of the Milky Way is the supermassive black hole. But the supermassive black hole is not the dominant force of gravity in the Milky Way. It really accounts for less than 1%, like 0.1% of the mass of the Milky Way. The dominant force of gravity in the Milky Way is the dark matter halo that all of the stars and all of the gas and even that supermassive black hole are embedded within. And this giant dark matter halo is turning. And we, all of the stars inside the disk of the Milky Way, are embedded within that halo and turning with it. So yes, if you were to like form a rough circle that the path that you would be taking around the Milky Way, at the center of that is a supermassive black hole. But to say that you were orbiting around it, it is not the thing that is holding you in place. It is the sort of sum gravity of all of the stars in the Milky Way, all of the gas, all of the dust, as well as that halo of dark matter. drZab, instead of building space stations or sending mini starships like SpaceX wants to do, wouldn't it make more sense to build a real spaceship and assemble it in orbit? I don't know, what is a real spaceship? The plan is that Starship is a reusable spaceship. And so you launch it from Earth, you fill it with fuel from multiple starships, and then you launch it towards some distant destination. And because the Starship is reusable, then you can just continue to reuse the spaceship itself. The only cost is the cost of the fuel. And theoretically, a full tank of fuel for a Starship is, a few $100,000. It's not that expensive. Now, I'm sure reality is going to end up like, it turns out it's way more expensive than we ever thought. Who would have guessed? It's not like we're seeing the Falcon 9 prices come down to just the very cost of the fuel. But this goes back to my old issue, is that we don't have a lot of infrastructure in orbit right now. So I can imagine some future where we do have some kind of orbital space station, an orbital shipyard that can 3D print various bits and pieces that are required for a spaceship. And then you can send up just the parts that have to be manufactured on Earth. And because the thing was built in space, has never come down to Earth, it doesn't have to have a shape that can handle landing on Earth. So the idea is very elegant, and it's the kind of thing that a future version of humanity will eventually get around to. But right now, we are just barely learning how to do this. And so it's just baby steps right now. Did you know you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call that Q&A Plus. And this week's bonus question, what's happening with space elevators? And I'll put a link in the show notes to that episode. All right, those are all the questions that we had this week. Thank you, everyone who put your questions into the YouTube comments, everybody who joined us for the live show. And just another reminder that the last live show of the season is going to be happening on Monday at 5 p.m. Pacific time. So if you're going to be around and you want to experience the full 2-hour live stream experience, you should come and join us. Now, I'm going to talk about the Alpocalypse, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Barry Lake Roofing, Brian Bodie, Carradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Gilton, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Smits, Michael Purcell, Modzo, Paul Roebuck, Rank Haidu, Robeck, Sean Sargent, Stephen Fowler-Munley, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So people who run websites like me, I run the website Universe Today, experienced something pretty catastrophic in May. And the name for this is going around is now the Alpocalypse, the algorithm apocalypse. And this is when Google rolled out their new AI search feature. And so if you do a search on Google now, you get the AI boil down of the facts that you're looking for. And now they're rolling out a new version of that, which essentially replaces the search results with an interactive AI conversation. And the effect of this has been dramatic for websites, which is that nobody uses Google to get to your website anymore. And for a lot of people, this is the end. That for a lot of websites, they're done. Social media isn't sending traffic to websites anymore. Google isn't sending traffic to websites anymore. You know, even if you're producing amazing content, no one's going to find it. And, it's not, we don't, aren't supposed to get anything from Google. It's not our right. But it is going to make it very difficult for people to gain new audience. And so, while we're going through this process, a lot of the websites that you enjoy are going to disappear. They're just going to go offline. And that's just the reality. But the way you can prevent that a little bit is that these aren't going anywhere, right? These websites are still going to be there, still on the internet. It's just that the methods that we have all become accustomed to finding these things are subverting the traffic to other directions. And so there are a lot of great technologies that you can use to maintain steady contact with the creators that you enjoy. And the tool that I recommend is RSS, which is a real syndicated service. RSS. And you can get an RSS reader. Now, Google used to have an RSS reader, but they killed it. I like Feedly, but there are a lot of RSS readers out there, and all of the websites that you enjoy are going to have an RSS feed that you can subscribe to. And then you, whenever they write a new article, or whenever they make a new post, or whenever they review a new game, or whatever it is that you enjoy from that content creator, you'll get a notification, and then you can go and check that out. Because none of this stuff is going to find its way to you anymore. Not in social media, not through Google, not through news, none of this stuff. You're going to be cut off if you rely on those. So take the power back into your own hands, curate your own the way that you interact with websites on the internet, and make a direct connection with the people who create. This is the way the web was supposed to be. This is how it started. And it just became worse with all of these middlemen and all these layers in between. So RSS, go back. And of course, Universe Today, we have an RSS feed, and you should definitely check that out. All right. We'll see you next time.